The James Webb Space Telescope (JWST) project ensured the most detailed and sharp infrared photographs of distant systems, investigating the past to help answer mysteries concerning the universe's beginnings. Following its journey of over 1 million miles from Earth, and spending months gathering data from the outer reaches of space, the telescope has begun sharing a full array of images with NASA. This allows us to see stars and systems as they were billions of years ago. The telescope grants us the ability to look further into space than ever before. Since then, this remarkable NASA project has produced a wealth of stunning images. The JWST has delivered sharp and well-organized pictures that are truly breathtaking. However, the JWST is not just there to amaze us. As stated by NASA experts, its work will be crucial for understanding both the universe as it is now and its underlying history. What new information and data do we have from the JWST and the Hubble Space Telescope? The James Webb Space Telescope, renowned for its captivating photographs of the universe, has once again succeeded with its most detailed picture of Neptune. NASA's JWST shows its capabilities not only in distant observations but also by providing the best look at the planet's rings in over 30 years. Its cameras have shed new insights on the ice giants. The clarity of the planet's rings, some of which have not been seen since NASA's Voyager 2 became the first spacecraft to look at Neptune during its flyby in 1989, stands out in JWST's latest image. The Webb picture clearly shows Neptune's fainter dust bands in addition to various thin rings. According to Heidi Hamel, a Neptune system expert and transdisciplinary scientist at Webb, it has been 3 decades since we last saw these faint, dusty rings, and this is the first time we have observed them in infrared. These delicate rings were found so close to Neptune, making this record of the JWST particularly consistent and detailed. Since it was discovered in 1846, Neptune has fascinated scientists. Neptune orbits in the far-off, faint outer solar system, many times further from the Sun than Earth. The high noon on Neptune is akin to a dim sunset on Earth, considering how small and pale the Sun appears from such a great distance. The internal composition of this planet qualifies it as an ice giant, as Neptune is significantly richer in elements heavier than hydrogen and helium than the gas giants Jupiter and Saturn. Small amounts of gaseous methane give Neptune its characteristic blue color in Hubble Space Telescope photos at visible frequencies. However, Neptune does not appear blue to the Webb, as its near-infrared camera, NIRCam, only detects objects in the near-infrared range, between 0.6 and 5 microns. In fact, the planet is quite dark at these near-infrared frequencies due to the significant absorption of red and infrared light by methane gas, except in areas with high-altitude clouds. These striking streaks and spots of methane ice clouds are noticeable as they reflect light before it is absorbed by methane gas. Over the years, images from various observatories, such as the W.M. Keck Observatory and the Hubble Space Telescope, have captured these rapidly changing cloud features, offering a more discrete visual signature of the atmosphere that drives Neptune's winds and storms. A thin line of brightness encircles the planet's equator, where the atmosphere sinks and warms, causing it to appear lighter in infrared frequencies compared to the cooler gases nearby. Neptune's northern pole, near the top of this image, is difficult to observe due to its 164-year orbit, but the JWST images suggest an unusual phenomenon. The JWST picture clearly shows a previously known vortex around the southern pole. Additionally, this is the first time the JWST has shown a consistent band of high-altitude clouds encompassing its 7 of the 14 known moons. 2 moons were discovered by JWST, and a particularly striking feature of light, with the specific diffraction spikes found in many JWST images, enhances this depiction of Neptune. However, this bright object is not a star, it is Triton, Neptune's large, unusual moon. Triton reflects about 70% of the sunlight it receives, thanks to a frozen coating of solid nitrogen. Because methane absorbs at these near-infrared frequencies, Triton significantly outshines Neptune in this photograph. Triton's unique retrograde orbit around Neptune has led astronomers to speculate that this moon was once a Kuiper belt object that was gravitationally captured by Neptune. Furthermore, the James Webb Space Telescope has captured its most important images of Mars by carefully noting infrared light coming from the planet. On September 19, 2022, at the Europlanet Science Congress, EPS 2022, the first photos and spectra of Mars from the JWST were revealed. The images of Mars were taken from a distance of 1.6 million kilometers. The photos show the visible disk or the side of the planet facing the telescope that is illuminated by the sun, captured by the JWST's near-infrared camera, NIRCam. These images could offer planetary scientists a better perspective of Earth's neighboring planet, as well as provide data that can be used alongside insights gained from rovers like NASA's Perseverance. It is not the least challenging task for the JWST, which is designed to observe extremely distant and faint objects, to also see Mars, which is relatively close and very bright. Astronomers can focus on current phenomena, such as Martian atmospheric conditions, dust storms, and even changes caused by the planet's seasons. Thanks to the JWST's ability to capture images and spectra with the spatial resolution they require, the telescope also observed simultaneous views of events occurring throughout the Martian day, including during sunrise and sunset. The eastern portion of the Martian surface is depicted in two distinct wavelengths of light in the JWST's initial images of the planet. Reflected sunlight dominates the short wavelength image, which shows parts of the Martian surface that reflect those specific wavelengths. These features include the massive, faint volcanic rock in the Hellas Planitia, a nearly 2,800-kilometer-wide impact crater. Mars releases longer infrared frequencies as it loses heat, as captured by the NCAM camera on the Webb Space Telescope. The most splendid and hottest area of this light is seen where the sun is primarily overhead on the planet, and this is associated with the temperature of Mars and its atmosphere. The quality decreases in the northern portion of the globe, which is currently experiencing Martian winter, and in the polar areas of Mars that receive less sunlight. However, the amount of light that the JWST captures is not solely dependent on the planet's temperature. The chemical compositions of the Martian atmosphere and surface can also be understood from the telescope's images. Cosmologists could potentially learn more about Mars' climate and surface by using data from the James Webb Space Telescope to explore the range of light that was detected coming from the planet during the hottest part of the Martian day. The 1,200-meter Hell's Bowl appears darker than its environmental components, according to an analysis of the JWST images. This effect creates a noticeable darkening, which is the result of light entering the Martian atmosphere and being absorbed by carbon dioxide. The new photographs also demonstrate how the James Webb Space Telescope could investigate Mars using measurements made with the telescope's near-infrared spectrograph (NIR-SPEC) instrument. This methodology, known as spectroscopy, allows planetary scientists to analyze the fingerprints that different chemicals leave in the light emitted from a planet's atmosphere to determine its composition. Since chemical compounds absorb and emit light at specific frequencies, the scientists' initial discoveries reveal intricate patterns encoded with details about Martian composition. Frozen fogs, which contribute to the atmosphere, and minerals visible on the planet's surface, such as water, carbon dioxide, carbon monoxide, and other chemical components, should be detectable by JWST observations. Methane is particularly significant because it can inform planetary scientists about a variety of geological processes occurring on Mars, including whether a significant impact has recently occurred. Methane may also provide evidence of past biological activity on the planet. The first clear indication of carbon dioxide in an exoplanet's atmosphere has also been recorded by the Webb telescope. This discovery not only offers intriguing clues about how the exoplanet formed but also serves as a preview of what the future holds as Webb increasingly explores extraterrestrial planets. The data displayed in a plot lacks the grandeur of Webb's previous images, which featured worlds caught in a grandiose dance amid stunning nebulae. Nonetheless, the data are beautiful, according to Jesse Christensen, an astronomer at the NASA Exoplanet Science Institute at the California Institute of Technology in Pasadena. The exoplanet WASP-39b is known as a hot Jupiter because it has a size similar to Jupiter, but orbits its star much closer than Mercury orbits the Sun, making it exceedingly warm. The plot provides structured information about the atmosphere of the exoplanet, which is over 200 parsecs away from Earth. It was first spotted through ground-based telescopes in 2003 and was subsequently observed by NASA's Spitzer Space Telescope, which operated from 2003 to 2020. Although Spitzer's data were inconclusive, they raised the possibility that WASP-39b's atmosphere contains carbon dioxide. Then Webb came into the picture on July 10, with the infrared telescope tracking the planet as it crossed the face of its star for nearly 8 hours. During this period, light penetrated the planet's atmosphere and was absorbed by specific particles at certain infrared light frequencies. Scientists anticipated that carbon dioxide would manifest as a noticeable blip in the spectrum. Natalie Balda, a space scientist at the University of California, Santa Cruz, UCSC, is the group leader for networks studying exoplanet early atmospheric science. There it was, just jumping off the computer screen, she says. The results bolstered confidence that Webb will be a key tool in future exoplanet research. Game changer for exoplanet research, the telescope is mentioned to have seen 76 exoplanets in its most vital year of movement alone. The total could reach hundreds generally through its lifetime. It will glance through the conditions of little, possibly Earth-like, rocky worlds and gas giants, finding carbon dioxide. However, it is important to note that one may reasonably surmise that a planet like Jupiter, which sprang from a similar cloud of material as its star, would share the star's compound creation. Yet, neither WASP-39b nor our own planetary system fits this case. Strong carbon dioxide signals from the exoplanet show that it is loaded with heavier elements than the hydrogen and helium that normally make up stars. For what reason is this significant? The account begins to explore the possibility that comets and asteroids struck WASP-39b when it was young, delivering heavier elements like carbon and oxygen. Observing this is interesting. The exoplanet appears to contain a similar amount of heavy elements as Saturn, which scientists also believe had a stormy youth. WASP-39b may have formed from materials in the cold outer regions of its planetary system before migrating inward when it reached its critical resting place. It was close to its host star, which may have influenced the loss of a portion of the hydrogen from the exoplanet's atmosphere, concentrating the heavier elements and increasing the carbon dioxide levels. Articles assessing these possible outcomes and examining the planet's composition in greater detail are currently being developed by scientists. Finding carbon dioxide in a planet's atmosphere is a crucial step in the search for life beyond Earth. However, WASP-39b is considered too close to its star to support life, according to cosmologists, who also do not expect the James Webb Space Telescope to find clear evidence of extraterrestrial life. Carbon dioxide and methane in a planet's atmosphere are thought to be indicators of life, as per space specialists. Ultimately, finding life will likely require an observatory much more advanced than Webb. To prepare for that future development, we must navigate this incredibly critical time. The Hubble Space Telescope has made significant strides in its mission to measure the rate at which the universe is expanding, which aligns with the idea that something extraordinary is happening in the universe. Cosmologists have previously utilized telescopes like Hubble to definitively measure how quickly the universe is expanding, but as those assessments have improved in accuracy, they have also uncovered a discrepancy when compared to measurements made shortly after the Big Bang. There is a significant difference in the speeds of the universe's expansion. As it stands, this discrepancy is beyond the comprehension of scientists. However, it suggests that something unusual is occurring in our universe, which might be the result of unknown dark energy. For the past 30 years, Hubble has been gathering data on a variety of cosmic markers that can be used to track the speed of the universe's expansion as it moves farther away from Earth. According to its latest findings, Hubble has now calibrated more than 40 of these markers, enabling much greater accuracy. Nobel Prize winner Adam Rees of the Space Telescope Science Institute, STS, and Johns Hopkins University in Baltimore stated in a decree, "You are getting the most trustworthy estimate of the expansion speed of the universe from the best array of telescopes and numerous cosmic markers." When American astronomer Edwin Hubble observed that galaxies beyond our own appear to move away from us, and do so faster the further away they are, the mission for an accurate measurement of how quickly space was expanding began. This is a time of extraordinary discoveries, and we are eagerly awaiting each one of them. Thank you for watching one more episode of Voyager.